This lecture is going to be a very interesting one because we are going to create our first sketch which is completely constrained. Let us open a new file. We'll click on this new and we'll select part here. Click on OK. Now we are inside the 3D modeling application of Creo. We want to get inside the sketcher interface of Creo. So for that we will select the sketch icon and we'll select this plane. Click on sketch and we'll select this icon which is orient sketch. Now we are inside the 2D plane of the sketcher. Here we are going to develop a fully constrained geometry of a rectangle. We'll give the dimension of the rectangle as 100 into 50. Now we have already seen how to create lines. So let us create 4 lines and we will generate the rectangle. Click on line and we will select a point maybe somewhere here and a point maybe here, a point here, maybe a point here, and we'll select a point somewhere here. Press on the escape key to exit from the command and you can see some numbers have come. These are the dimensions. These are all a part of the dimensional constraining. Now definitely this figure doesn't look like a rectangle. So in order to create a rectangle, we have to give the constraints. Here the very first constraint that I am going to give is I want to close this sketch so that it will be a quadrilateral. So for that I need to coincide this point with this endpoint. For that we are going to use the coincidence constraint. Here this is the geometrical constraint and coincident is a geometrical constraint. So I'll use this icon which is coincident. Click on coincident. Just select this point and select this point and you can see the sketch is completely closed, which is visually displayed by using this pink color. If this pink color filling is there inside any sketch, that means it is completely closed. Now let us go for giving the other constraint. Here you can see these are all the dimensional constraints. All the numbers that you see are the dimensional constraints. First let us give the geometrical constraints. Then we'll move on to the dimensional constraints. Of course it doesn't look like a rectangle because in rectangle this has to be vertical, this is horizontal, this also should be vertical and this should be horizontal. So first let us give the vertical constraint to this line. For that we will use this icon which is the vertical icon. Click on vertical and when you select this line, immediately the vertical constraint is getting used for this line, which is displayed by this symbol. You can see this symbol indicates this is a vertical constraint that has been given to this line. Now we'll select this icon which is horizontal icon and we'll select this line so that it will become horizontal. And you can see this symbol. This is horizontal constraint symbol. Now let us go for creating another constraint which is perpendicular. We want to make these two lines perpendicular. So let us go for perpendicular constraint, which is this icon. Click on perpendicular constraint, select this line and this line, and you can see both of them have been given a constraint perpendicular, which is indicated by this symbol. Now let us go for creating these two as parallel. For that we will use this icon which is parallel. Click on it, select this line and this line, and you can see it looks something like a rectangle. Now press on the escape key to exit from the constraints command and let us give the dimensions. Here if you see, some auto dimensions have been given. These are the auto dimensions that have been given. We can give the dimensions automatically and also we can give it manually. In Creo, when you create a geometry, automatically the dimensions get generated. You can use the auto dimensions or you can also create your new ones. Let us use two of the auto dimensions, which is this length. I'll just double click this and type 100. Press on the enter key because we want to create 100 into 50 rectangle. You can see this is 100 and this we want to give as 50. 50. Enter. You can see the rectangle has been made. Now there is one more thing that we have to know in Creo. If I move this line by using the left click, I'll press the left click and keep and move the mouse. You can see this dimension is changing. I'll use Ctrl plus Z key to undo. Now, if I don't want this 50 to change, I'll just select this and lock this dimension. Now what will happen is, you can see the 50 doesn't change. The dimension is locked. Now, if you want the same thing for this 100, you can do it. Just select it and lock. If you move, the 100 will also not change. Now, why does it move? As we have already given the dimensional constraints and the geometrical constraints, still the object moves. Because for final constraining, you have to give the reference with the datum coordinate system, which is this x, y and z. This is the datum coordinate system represented by this line and this line. This is the x-axis and this is the y-axis or the z-axis. This is one axis and this is another axis. So you have to give the reference with these two axes. For that, you can see these two dimensions have been given. But we don't want that dimension. I want to keep this origin in this center. So for that, I'll give some manual dimensions. You can also move this and keep, but let us give the manual dimensions so that we will see how to give the manual dimensions. I'll click on this dimensioning. This is the dimensional constraints. I'll click on dimension. I'll select this line and select this axis. And I'll click on the middle mouse button. And you can see the dimension has been given. We'll give a dimension to this as 50, enter 50. So the object is symmetric about this axis. Similarly, I want to keep the object symmetric about this axis. So what I'll do? I'll take dimension again. I'll select this line and this axis and press the mouse middle button. You can see a dimension has been given. And here we will give half of 50. So 25. 25, enter. And you can see here our figure is completely constrained. Now press on the escape key to exit from the dimensional constraints. Let us move this line. Of course, this line will change and also this also will change because we have not locked it. Press on the Ctrl plus Z key to undo and select this dimension, lock, select this dimension and lock. If you move this, you can see it doesn't move. So what it means is this object is completely constrained. So we have created in this lecture a completely constrained rectangle of 100 mm into 50 mm. In this lecture, we are going to see how to create auto constraints and manual constraints. Of course, in the last lecture also we have seen, but in this lecture we are going to elaborate. Here, we are inside the sketcher interface of a new file in Creo. Let us create the same rectangle again, which is 100 into 50 rectangle. This time, I'll select this line In the last lecture, I have created 4 lines in a different shape. But in this lecture, we are going to discuss shortcuts for generating that rectangle. Let us select somewhere here. And as soon as I move down, you can see a vertical constraint is being given and the line is getting locked. You just have to move your mouse. You can see it is getting locked. Once it gets locked, when you click, automatically a vertical constraint is getting generated and the line becomes vertical. Similarly, if you move here, you can see this is horizontal. Click and a horizontal constraint is given to this created line. When you move up, you can see there are few constraints that are getting generated. If you move, you can see at this point there is also a equal constraint that is being given. You can see equal constraint. When I click here and again move, if I come here, automatically the coincidence constraint is getting generated. When I click, you can see the rectangle has been formed. Press on the escape key to exit from the command and you can see a completely closed rectangle has been formed. Even the dimensions also, if you see, whatever we require, that has been given automatically. So this is the power of auto constraints in Creo. I'll double click on this dimension and I'll give it as 25. Press on the enter key. Again, I'll double click on this dimension and give as 50. Press on the enter key. You can see here. Now, I'll double click on this dimension. I'll give as 50. Enter. And we will double click on this dimension and give 100. And you can see our 100 into 50 rectangle has been given. Now, let us position these constraints near to the sketch so that we can have a clear visualization on what actually we have given. And you can see the same thing we have created in the last lecture, but with great difficulty. But it was actually needed so that you can understand the difference between manual constraining and auto constraining. In the last lecture, we have done many things manually, but here everything we have done automatically. So, I'm not saying that auto constraint is good and manual constraint is bad. What I am saying is both of these constraining methods have their own role. So, we should be aware of both the things and we should be able to utilize both the constraining methods. In the next lecture, we are going to create example 1 drawing and we are going to be very clear on this concept of constraining. In this video, we are going to create a completely constrained geometry of example 1. Here you can see this is example 1. First, we are going to create this entire boundary and then we are going to give the dimensions and of course the geometrical constraints to completely constrain this sketch. Let us start. Here I have created a new file and now I am inside the sketcher workbench of the new file. Let us create the rough sketch. We'll click on this line tool, the line chain tool, and let us create a rough sketch. I'll click here and create a vertical line. You can see the line is getting snapped here and we will be able to create a vertical line. Click. This is a horizontal line. Let us zoom in a bit. Let us create the rough sketch. Click here. If you move, you can see another constraint is getting formed. This is an auto constraint that is getting formed, such as the vertical and the horizontal constraint. This auto constraint is called equality. So what this means is the line which is getting formed now will be equal with respect to the green line. We don't want that. So we'll just move it and make it somewhere here. Again, we'll move up. You can see that equal symbol is again coming up. We don't want that. Click here. So you have to form the lines such that this unnecessary constraints doesn't get involved. Otherwise, it will be a hectic situation to find out which constraint is creating the problem. I'll click somewhere here and maybe join. Click on the escape key. You can see a completely closed geometry has been created. Now let us give the constraints. We'll start by creating this line as horizontal. So we'll select this horizontal constraint and select this line. You can see. Now let us give the geometrical constraints first. Now if you see the drawing here, this line is 20 mm, this is 20, this is 20 and this is also 20. So all these four lines are equal. Let us give the relation of equality between these four lines. First, let us take the dimension of one line. You can see the dimension is given here. So just double click on this dimension and if you see here the dimension is 20. Let us give 20 to this line. Now we will take equality. You can see this is equal constraint. Click on it. This line and this line are equal. You can see that constraint has come. Again, this line and this line are equal. This line and this line are equal. Now let us go for the other dimensions. We'll take dimensional constraint. This entire length is 100 mm. You can see this entire length has been given here. Press on the escape key to exit from the command. You can see. Just double click on this and we will give this as 50. Now if you want to lock these dimensions, just click on this dimension and lock it so that it will not change. Even this dimension also, if we lock it, it's better so that it doesn't change while we move the object. Now let us give the other dimensions. Here this 20 we have given, 50 we have given and 100 we have given. The next dimension is this 25 and 12.5. This dimension is also 25. So we can give a relation between this line and this line as equality. Let us first give equality, then we will proceed. This line is equal to this line. And let us give the dimension of this line. You can see the dimension is already given here. So we can just double click on this and give 25. Similarly, here also the dimension has been given. This is 12.5. This length is also 50. So we can give a coincidence constraint between this line and this line. And you can see all the dimensions have been given. But still the figure is not completely constrained because we have not given the dimension with the references. If I hold this and move, you can see it is moving. These two dimensions we have not locked, so that's why this figure is defiguring. Now after I lock it, if I move, you can see it's not defiguring. So I really advise locking the dimensions is the best option. Now let us go for coinciding this line with this axis. Again, we can go for coinciding this line with this axis. And this figure is completely constrained. Press on the escape key. And now if I want to move it, press the left mouse button on the line and move the mouse. You have to keep pressing the left mouse button and move the mouse. So you can see we have created a completely constrained geometry of example 1. In this lecture, we are going to discuss about over-constrained and conflicting constrained geometry. Here you can see I have a rectangle. Now, in this rectangle, suppose if I use some other constraints, maybe this and this, both are parallel. Suppose I say I will make this line perpendicular to this line, which is not possible. So let us give a constraint and see what happens. Here I'll take perpendicularity constraint and I will select this line and I want to make this horizontal line perpendicular with this horizontal line. You can see it is showing a conflicting constraint dialog box where it says resolve sketch and it gives a hint the highlighted three constraints conflict. Select one to delete or convert. What it means is this is a horizontal constraint and we have a vertical constraint here. Now another constraint we are giving which is perpendicularly between these two constraints. So these three constraints are creating a conflict. So we have to delete any one constraint. This constraint we have given now, which is not required. So we will go for undo or we can also go for delete. You can see. So this is conflicting constraint, which means you have given a constraint and again you are giving another constraint which is conflicting that constraint that you have given. Like I have shown you, these lines are horizontal, so automatically they are parallel to each other. But if you give a perpendicular constraint to that, then it is a conflict. Two parallel lines cannot be perpendicular. So you have to decide which constraint you should keep and which constraint you should delete. Now coming on to over constraint geometry. Here in this rectangle, as it is a rectangle, so opposite sides are equal. So this line is equal to this line. Suppose again I give equal constraint. Click on equal. This line is equal to this. It will show the same conflicting constraint, but here it is considered as a over constraint because if these two vertical constraints are given to these two lines, then automatically these two horizontal lines will be equal. So if you want, you can delete any of this constraint and your geometry becomes stable. It depends on your requirement. I'll go for undo here. Suppose we give another dimension, this line, which should be equal to 392. Let us see. But before that, let us lock the dimension. Now let us go for dimension and click on this line and click here. Here you can see it's over constrained dialog box where it is saying to resolve the sketch. Here what it means is these three are conflicting. Here this dimension and equal constraint is conflicting. Suppose I will delete this equal length and let these two dimensions be there. So here that equal constraint is removed and we have only these two dimensions. To this 393, let us give a value 200. You can see as the equal constraint has been removed, so we are able to give different lengths. So this is over constraining and conflicting geometries. This